Okay, this video will be about when numbers are rounded up and how we write the bounds in which the numbers can lie. So if we have a quick look at this, the number 90 has been rounded to the nearest 10. Write the bounds in which the number can lie. Now what we want is the biggest and the smallest in which this number can lie. So the initial thoughts by students often think, okay, the smallest number is 85 and the biggest number is 90. Well, they often think it cannot be 94.5. So often students write this, and this is a common mistake that you shouldn't do. They write 94.9999 or whatever they want to write. Whatever they do, we can always put an extra 9 on the end. So in fact, even though it looks incorrect, we're actually going to write down 95. And there's an easy way to remember this. Look at the difference between 85 and 95. It's 10. The nearest 10. Now, students will often say, or people often say, well, if the number is 95, it won't round down to 90, it'll round up to 100. And so we have a special way to get around that. And that's, we write 85, we use the inequality, it can be greater than or equal to. We use the 90 because that's the one that's rounded up. And this time we use just a less than sign. So it's just less than 95. So we're saying anything less than 95. Now, quick way to do this is to just take the number 10, take 10, because that's what it's rounded up to, divided by 2 gives me 5. And notice that this is 90, take away 5, and 90, add 5 in this inequality. So we're going to do a couple of others. And we're going to use this method. So we're going to look for what it's rounded up to, divide by 2, and add and take away from this number. So the number 600 has been rounded to the nearest 100. So straight away, I take 100, nearest 100. I divide by 2, and I get 50. I take 50 away from 600. Get 550. I'll write 600 here because that's the rounded number, and then remember the inequality sign here is just less than, and 50 plus 600, 650. And that's a simple way to do it. Okay, we'll come on to two harder ones. This is the number 12.7. There's a little point in there. 12.7 has been rounded to the nearest decimal place. So one decimal place, that's what they're saying it's been rounded to. So I'm going to write down one decimal place, and I'm going to divide that by 2. Remember, we divided 10 by 2 to the nearest 10. We divided 100 by 2 to the nearest 100. So this gives me 0.05. And I'm going to take that away from 12.7. So I have 12.65, and I use the equal bit on the inequality, and here's the number that was rounded, 12.7, and then less than 12.75. So nearest decimal place, use 0.1. Two decimal places, 0.01 divided by 2. And the final one is the number 34,200 has been rounded to 3 significant figures, 1, 2, 3. In this case, the third significant figure is in the hundreds. So just for this one, the third significant figure being in the hundreds makes it 100 divided by 2. So you look where the third significant figure is and decide what place value it is. If the third significant figure had been here, if it was 3420, we would have taken the 4. So we divide that by 2 like we have been doing all the way through, and we've got 3, 4, 150. And then we use an equal sign, 3, 4, 2, 0, the rounded number, less than 3, 4, 2, and add that 50 on. Now there's a couple of exceptions to the rule, and you can see that in a later video, but just for these numbers, which are known as continuous numbers, this works fine.